Dr. James Lathrop Meriam, known to his colleagues as Lath, was one of the most influential engineering educators of the 20th century. His textbook, Engineering Mechanics, Statics, reshaped how mechanics is taught across the globe. Today, we imagine a conversation with Dr. Meriam, drawing from his biography and the enduring legacy of his work. Dr. Meriam, thank you for joining us. Let's begin with your journey. You earned 3 degrees from Yale, served in the Coast Guard during World War II, and taught at Berkeley, Duke, and Cal Poly. What drew you to engineering mechanics?
Mechanics is the language of engineering. Whether you're designing a bridge, a turbine, or a robotic arm, you're dealing with forces, motion, and equilibrium. I saw mechanics not just as a subject, but as a way of thinking.
Your textbook preface describes mechanics as both a foundation and a framework. Could you elaborate?
Statics and dynamics underpin nearly every branch of engineering: civil, mechanical, aerospace, even electrical. Even in a discipline such as electrical engineering, practitioners, in the course of considering the electrical components of a robotic device or a manufacturing process, may find themselves first having to deal with the mechanics involved. Mechanics connects disciplines.
Your books emphasize problem formulation over mere solution. Why is that distinction important?
Formulating a problem develops judgment. It forces students to ask, what matters here? What assumptions are valid? That's where learning happens. Computers are useful, but they must never replace reasoning.
You've written that theory should approximate reality, not the other way around. What does that mean for students?
It means humility. Our models are tools, not truths. Students must learn that mechanics is an approximation of the physical world, not a perfect mirror. That mindset fosters better engineers.
Your textbooks are known for their high-quality illustrations. Why such emphasis on visual clarity?
Mechanics is geometric. If students can't visualize forces, they can't understand them. We used red for forces, green for velocities, orange for trajectories, because color helps cognition. Graphics aren't decoration, they're pedagogy.
You've expressed concern about trends in engineering education, especially the decline of graphics and geometric intuition. What's at stake?
When we replace geometry with notation, we lose meaning. Mechanics depends on spatial reasoning. We must restore emphasis on drawing, visualizing, and interpreting, not just symbol manipulation.
Your textbooks include hundreds of problems, introductory, representative, computer-oriented. How did you approach problem design?
Each problem is a conversation. Introductory ones build confidence. Representative ones challenge reasoning. Computer problems must be real, not artificial. And we balanced SI and US units to reflect global practice.
Many of your problems relate to design, even if not labeled as such. Was that intentional?
Absolutely. Statics is not just analysis, it's design thinking. Every force diagram is a design decision. I wanted students to see mechanics as a tool for creation, not just calculation.
Outside academia, you built a sailboat and designed homes. What connects those pursuits to teaching?
Design is universal. Whether it's a sailboat or a syllabus, it's about harmony and purpose.
I spent 3 years building Melekai and decades building a curriculum. Both required patience, precision, and joy.
Dr. Meriam passed away in 2000, but his legacy lives on. His textbooks remain the gold standard in mechanics education. His philosophy, rooted in clarity, rigor, and respect for the learner, continues to guide educators worldwide.